Okay, so now we're going to continue our number patterns, this time through multiplication and division. And again, we're going to be looking for patterns. So, and see if we can name them. So let's start with the first one. Remembering this time we're looking for multiplication and division. So 1 to 2, 2 to 4, 4 to 8, 8 to 16. It looks like it's doubling every time. So doubling is timesing by 2. So if I doubled 16, I would get 32. If I doubled 32, I get 64. If I doubled 64, I get 128. So this would be double the previous number. Starting at 1. Now, funnily enough, I think this one's just halving. I'm going to make this pen a little bit easier to read. Here we go. So, if we go from 32 to 16, this time we're halving it. So times by half. And we're going to halve it again from 16 to 8. And halve it again from 8 to 4, which would mean we would halve it again. From 4 to 2, we would halve it again to get to 1, and we would halve it again. Half of 1 is a half. So this would be halve previous number, starting at 32. Okay, what's going on here? 3, 6, 9, 12. Well, that sounds like the multiples of 3. So what's happening here with that's times by 2. That's, oh, I know, this is an addition sum. I don't know what it's doing in this set, but let's that's plus 3, and that's plus 3, and that's plus 3. So the next one would be plus 3. That'd be 15. And that one would be plus 3. That would be 18. And that one would be plus 3. That would be 21. Now I know why this has been included in the multiplication set, because these are actually the multiples of 3. And if we look at it this way, 1, 2, 3, 4, 5, 6. Say this was the position. So 1 would be the first number and 2 would be the second number. There's the numbers from this sequence. And if you look at the position compared to the number, x is always equal to the position times by 3. So 1 times 3 is 3, 2 times 3 is 6, 3 times 3 is 9, 4 times 3 is 12, 5 times 3 is 15, 6 times 3 is 18. So we could change this answer underneath and call it the position in the sequence times 3. Actually, I'll take out the arrows because they're not dealing with arrows this time, just positions. And it's a different way of thinking about a problem. Rather than thinking of it in terms of the previous value, we're going to think about it in terms of the position it is in the sequence. So that would be position times 3. Position times 3. Position times 3. Position times 3, so on and so forth. Whereas this is the first position, the second position, the third position, the fourth position, the fifth position, the sixth position, the seventh position. So let's write that on the right hand side. Position times 3. And if we look at this one, this is the multiples of 4. So 4, 8, 12, add 4 would be 16, add 4 would be 24, add 4 would be 28. And this is the position times 4. So on and so forth. I'll write that one over here. Position times 4, or increase by 4, start at 4. Or increase by 3, start at 3. Now this one, what's the pattern here? 3, 6, 12, 24. Looks like another doubling pattern, doesn't it? So that times 2, that times 2, that times 2. So that times 2 would be 48. That times 2 would be 96. That times 2 would be 200, take 8, which would be 192. So double previous number starting at 2. No, 3. Okay, what's happening here now? So looks like we times it by 4, then halve it, and then times it by 4. Yeah, that works. So from here to here, we times by 4, then we times by half, then we times by 4, then we times by half. Then we're going to times by 4. 8 4s are 32. Then we times by half, which will be 16. Then we times by 4, which will give us 64. So multiply by 4, halve number, start at 2. And there we go. There's some patterns that can be found through multiplication and division. I hope that helps.